Okay, so next we want to be able to use those average atomic masses in order to relate them to the number of particles. So again, mole is our big, big number that we're going to use repeatedly throughout this course, just like we did in first year chem. A mole is really an amount of atoms or particles. So just like the word dozen means 12, we can use the word mole to represent Avogadro's number, so 6.02 times 10 to the 23rd. Okay, and if you actually look in that AP periodic table and equations, it's given to you right in there, so you don't have to have it memorized. It's given right in there, but you do need to know how to use it. So last year we talked about all of these different types of conversions. We will certainly get into molarity and talking about gases later on, so we're going to kind of ignore this right side of this for now. But we certainly can talk about number of particles, and when we say particles, we can say atoms, we could say ions, we could say molecules. We could even say electrons. And as we go on in the year, we'll look at different things. But the number of particles of whatever type in 1 mole is always going to be this 6.02 times 10 to the 23rd. So we can relate that with Avogadro's number to get to moles, and if we want to go from moles to mass, we can use our molar masses here from the periodic table. Okay, so remember, those are always from the periodic table. So we can look at a couple of example problems then to think about how do we use that information to solve a problem. So our first problem that we're given here is talking about americium, which you might not know too much about, but it actually is probably in most of your homes. It's in your smoke detectors, and very small amounts of it can be basically produced in order to detect if there are particles in the air. And so it's saying how much mass would there be for a sample of americium that contains 6 atoms. So we're always going to start with what we know. So 6 atoms, and americium has the element symbol Am. And I want to end up getting that to grams of Am. And so if I'm thinking about atoms, atoms going to grams has to go through moles first. So I'm going to really go from particles to moles and then to grams. Okay, so each one of those arrows is going to represent a conversion factor that I'm going to have to use. So the first step is going to have to take atoms and change it into moles. And so atoms is going to have to be my unit on the bottom, so atoms of Am. And I know that I'm going to have to get that into moles. I can't compare things unless they're in moles. So the question is, what's that number that's going to go on the bottom? And so that is our Avogadro's number, 6.02 times 10 to the 23rd. So now I can see that my units of atoms have canceled out, and now I can move on to my second step. So now I have to get moles to turn into grams, and that's where I'm going to use the periodic table. So I know that my moles is going to have to be diagonal, so 1 mole of Am is going to be on the bottom, and now I'm going to use my periodic table to help me with the mass of americium. Now, the periodic table that you guys get from AP actually doesn't have masses down there, and that's because those are unstable atoms that we just don't find in any abundance. And so, but if I look back at our other periodic table, if we can make americium, we typically find that it has a mass of 243 for the particular atoms that we can make. And so now, again, I'm going to multiply across the top and divide by things on the bottom in order to get my grams. And so if I do that, I end up with an answer that is 2.42 times 10 to the negative 21, and that's grams of Am. Now, a couple of things to be careful of that I would mention last year. 2.42 to the negative 21 is not the same answer as times 10 to the 21, so be careful with how you're writing things. Make sure that you're careful with including that negative sign. It makes a big difference. And so those are just a couple tips. Let's take a look at another example. So for this one, I actually want you guys to try this one on your own. This time we're going to stop and pause the video and think about how would we solve this problem if we're starting with grams of aluminum, but this time we want to get to moles of atoms and then just numbers of atoms. So pause the video, try it right now, and then check and see how you did. Okay, so let's check and see how you did. So again, you should have started with your grams of aluminum. You want that unit to cancel, so it's going to have to be repeated on the bottom of your first conversion factor. Again, check that your units are canceling along the way. Moles is what's going to be opposite, so this is from the periodic table, and anything we get from the periodic table has to be for just 1 mole. Whenever I'm using the Avogadro's number, again, that's always for 1 mole. So again, I'm looking for my units to cancel diagonally. So again, moles of aluminum are canceling, and now I'm left with just atoms of aluminum. Notice the work that I'm showing, that's the evidence that I know what I'm doing, and it's clearly laid out. And so that's going to get you points on the AP test. If readers have to work, just like if I have to work when I'm grading a test, if readers have to work to find that you understand something, it's less likely they're going to give you points. Notice then that I'm recording my answer. I have 3 digits here, really because I had 3 digits at the beginning. And I'm including my unit and the chemical substance. Okay, let's try another one. Here we're calculating the number of moles and the mass. Oh, I just remembered that on that last one, we actually needed to say the number of moles. And so if we were going to do that, we would just really stop at this point in between the 2 steps and calculate to get our number of moles at this point. And so that would be actually 0.371 moles of aluminum. Okay? So let's go back to the next exercise. Again, I'd like you guys to pause and try this one on your own, and then we'll check. Okay, so let's see how you did. So again, you should have started out and you should have had what you were given, or what we know, 5 times 10 to the 20th atoms of cobalt. Again, with this one, just like with the last 2 problems, you really need to know how to use your scientific notation on your calculator. It's going to be really helpful to you. You know, we can certainly meet at some point if you, on a call if you need help with your calculator. We're going to use Avogadro's number on the bottom because, again, that's our number of particles, and atoms are particles. My moles is going to be on the top, and again, every time I use Avogadro's number, it's per 1 mole. So it asks me to find both the number of moles and the atoms in the sample, and so my number of moles would be what I would get after this first step. And so that's going to be 8.31 times 10 to the negative 4 moles of cobalt. If it's not showing up in scientific notation on your calculator, it would be 0.00831 moles of cobalt. And again, you know, unless I specify, you can put your answer in either way. And then we have to add on one more step if we want to get to grams, and so we'll use our molar mass. Again, that's from the periodic table. And so that ends up being 4.89 times 10 to the negative 2 grams, or 0.0489 grams of cobalt. Okay, so let's take a look at another thing that we have to pay attention to. And again, we learned this last year. Molar mass is just really the mass for a compound. So we've been talking about atomic masses or atomic weights, sometimes they are referred to, but molar mass is if we have compounds. So a couple of things to note that, you know, there are some kind of semantics here, but whether we're talking about molar mass or formula weight, we're really kind of talking about all the same thing. They can be represented in different ways. Two big M's sometimes for molar mass, MW for molecular weight, and again, that's typically talking about things that are molecular, meaning covalent, and so you can see kind of a description of that down here. But as opposed to formula weight is typically really for ionic compounds. I oftentimes will just use them all interchangeably, or I'll just talk about molar mass. And so, I wouldn't worry too much about it, but realize that there is some difference there. I don't know if I've ever seen a question asking you about those semantics on the AP test, so I wouldn't get too hung up on it. You should know, and it says this in the AP equation sheet, that AP just uses one capital M to represent all formula masses. And so there are a couple of equations in the section about gases, liquids, and solutions where a big capital M is representing molar mass. So you'll see that there.